Hi, everybody. Welcome back to AI Factories, Data Centers of the Future. We're here high above the options exchange after hours at the NYSE. My name is Dave Vellante, and we're here with Ken Patchett, who's the Vice President of Data Center Infrastructure at Lambda, named, of course, after our favorite math, Lambda Calculus, for all you function lovers. Ken, thanks for coming on. Great to see you.
Good to see you, Dave. I'm glad to be here.
So we are entering the gigawatt data center in a big way. We're seeing hundreds of billions of dollars, and we're going to, into the trillionaire era, massive build-outs. They call you the Superintelligence Cloud. I know you've got a lot of elements to your business that we want to get into, but where are we at in the rise of these specialized clouds? They call them neo clouds. You guys have been supporting developers. You've been supporting model builders. Give us the quick update on your business and your position in the space.
Yes. Well, I like to think about Lambda more as an emerging hyperscaler in that the data centers that we built in the past are still being built and still need to be used. But this newer data center to support artificial intelligence and really these large training models that are being built are very, very special. They're very purpose-built, and the density of hardware is such that the old data centers, meaning 2024 and behind, aren't really suitable any longer for the current deployment of the hardware that we're deploying. So Lambda is in the world of really moving and transforming the data center industry in such a way that we can support these large language learning models, these large training models that are being built around the world.
Okay, and so when I talk to enterprises, in particular, focus of our program here is enterprise AI. When I talk to enterprises, many of them, in fact, most of them, just aren't set up for liquid cooling. They maybe some have mainframes, and the old mainframe days, liquid cooling was a thing, but most enterprises hadn't been thinking about that until the AI heard around the world. So, what are you seeing there? Are you saying you are a solution for that? Are you a bridge to that world, or a combination?
Well, I think it's important to understand that Lambda acts as a platform, giving access to these GPUs. We believe one GPU, one person in the world. So when you think about the enterprise level player, the enterprise level player will be using the products that are created from these 128,000 GPU clusters that are being built around the world. And they'll have enterprise level data center space. So for instance, there'll be smaller data center space with 3 racks of GB300, some networking racks, and some other types of racks and storage that are there that they leverage and they use. And there'll be multi-density data centers that don't really exist today. Yesterday's data centers were between 2 and 15 kilowatts per rack. And now, right next to those racks, we have to put a rack that takes 130 kilowatts or 240 kilowatts. We have to think about how to cool it and things of that sort. So what happens is, with Lambda deploying a cloud platform, the enterprise level players are able to leverage the Lambda cloud platform, and they don't have to invest their own dollars into that or creating their own data center space. We're doing that for them.
Okay, so there's a theme. People talk about moving the AI to the data. Enterprises want to apply their proprietary sort of knowledge. They often say, well, we don't want to put it in the cloud, it's too expensive, or we don't want to move the data. At the same time, you guys are providing a service that is unique, in demand, not widely available necessarily in traditional clouds. That's how you came to be. How do you see that playing out? Can you accommodate that enterprise, and how do you accommodate that enterprise that wants that propriety, wants that control, but at the same time needs access to the GPU power and other infrastructure that you have?
Sure. Well, so Lambda has basically 2 products that we think about. It's called the private cloud and the public cloud. The public cloud, you can come to the Lambda website and you can say, I have this much time and this much money, and I can lease a GPU for a couple of hours. I can lease a number of GPUs for a week. I can lease them for a year. but it's a public cloud service. On the private cloud, we have the capability for an enterprise level company, for instance, to enter into a contract with Lambda and have access to a large number of GPUs, anywhere from about 64 to 20,000 or 30,000 or 40,000 GPUs for a length of time. And so Lambda provides the environment excuse me, Lambda provides the environment by which a machine learning person within any other company can leverage Lambda's GPU cloud and focus on the work that they want to do, and not focus on being an HPC compute engineer or worrying about how to orchestrate the GPUs. Our two products there allow you to focus on your job while the platform is simply just exists for you.
I want to ask you about GPU scarcity, and thank you for that, by the way. Sam Altman this week had, some very quotable commentary about we can solve, educating every person on the planet, or we can solve for cancer, and we can't do both because we don't have the GPU capacity. Of course, he's projecting sort of a forward. How do you think about that? I mean, is that first of all, is that truly where we're headed in your view as one of the leaders and the visionaries of what's possible with superintelligence, or whatever you want to call it, AGI? And are we actually having to make those trade-offs today? I mean, you guys are doing some amazing work in healthcare, in mathematics, in all kinds of fields. How are you making those trade-offs today, and how are you dealing with that scarcity of compute?
That's a good question. The scarcity of GPUs. The fact of the matter is, the waves of change are happening so fast in our industry right now that it is very difficult to keep up. A data center that has been built in the 1990s isn't suitable to support the GPUs or the hardware that's being built today. If you think about the rate of change, we're getting a new piece of hardware every 6 to 9 months, which changes the requirements of the data center that supports it. So the data centers have to keep up with the changing rate of the hardware. So the way we frame it in Lambda is the data center's DNA has to keep up with the changing DNA of the hardware. And our ability to ensure that we're working with our partners, because see, a rising tide floats all boat here. We're working with our partners to forecast into the future what is the right type of data center to build to support the GPUs that are created. Jensen is very clear in nearly every GTC that he's been in. We've done our job. We have created this amazing product. Now we need you to do yours. And what he means by that, or the way we take that, is you have to build the data center infrastructure that supports this hardware. So Lambda's working on ways to deploy data centers faster and quicker than ever before. We're thinking about the modularity. We like to think about data centers in terms of elements, where as the hardware changes, elements of a data center change. I may need more power. I may need less power. I may need more water. I may need less water. I may need more air. They all have elements to them. And we're working on ways to make sure that the data centers we're building right now future-proof into the future. And so it's really important to understand that the data centers are where these chips are going to go. So when we talk about a scarcity of chips, I think it's better to talk about a scarcity of appropriate data centers to house the very quickly changing requirements of the GPUs that are being created today. The data center space, these AI factories that we talk about, are the most important thing to enable not making those choices. Because listen, nobody wants to make a choice about researching for cancer or figuring out how to train every child in the world. Like one heartbeat, one diagnosis, right? That's what we need. We talk about often one student, one teacher. These are not trade-offs that we're making. We're actually using this as a force multiplier for us. A lot of people talk about AI, and we think about it differently, like it's happening like to us. That's not the way we think about a hammer. A hammer is a tool, and that tool multiplies our effect. So I think about artificial intelligence and the work we're doing as actually a tool that enhances our speed and capability of intellect and thought. And we don't make choices on doing this or that. We are making the choices to multiply our capabilities and actually use that as an enhancement to the human existence.
I mean, that aligns with, sort of visionaries like Ray Kurzweil, who says, look, once you get your hands on AI, you're not going to give it back. It makes you smarter. You're not going to want to be dumber. It makes a lot of sense. I want to come back to your one GPU, for every human. I called it a chicken in every pot, and when we were
I
talking
love
off
it.
camera. Is that vision? I'm inferring that you are prescribing that the best way to achieve that vision is with the surrounding type of infrastructure, the proper infrastructure that you all are building. Yeah, we'll have GPUs at the edge, we'll have them in our phones, but that vision will be in many respects, despite notwithstanding the centralized nature of the internet and the world, there will be massive pockets of centralized compute that will serve that vision. Is that the right way to think about it?
I think it's important to understand that much like the infrastructure that allowed horses to travel across nations and then vehicles following them are the most important thing here. We're building the infrastructure to allow this new superintelligence era to come into play. Let's be clear. We had 75 years ago, we entered into the information age. And in the last 30 to 35 years, it's been the network part of the information age. And here we are in one lifetime, shepherding in two different ages. The superintelligence age is what we're fortunate enough to be able to shepherd in. We've lived through scale. We've lived through the creation of infrastructure. Now we're building on top of that infrastructure. So I think what's really important to understand is this. In order to ensure that a GPU and the capability to access it and use it in your everyday life, and to be as ubiquitous as electricity in our existence, it requires the infrastructure to do that. Infrastructure takes time, takes money, it takes intent, and it takes partners. And Lambda looks across this industry, and our goal is to build the world's largest and greatest platform that many people can use, many companies, tens of thousands of companies can use to create products with. We can't do that alone. We have to do that with folks that know how to bring available power, to build the data center spaces, to work together for the MEP, the mechanical, electrical, and plumbing pipeline. It takes a large amount of people in our industry to actually deliver the infrastructure that then allows the power of technology to be available to everybody. That Lambda thinks about that in a very, very partnering way. We are bringing our partners with us.
So I want to ask you about sustainability and liquid cooling.
Yeah.
You talked about 128,000 GPU clusters. We're moving toward the era of, or the holy grail of 1 million GPU clusters, and we'll go beyond that. You mentioned 2 to 15 kilowatts per rack, being now up to 240 kilowatts per rack and rising. Last year at Supercompute in Atlanta, we had a panel on. We had a debate on liquid cooling, and we were debating, the single phase versus two phase. We actually had a company on. The name of the company was Omni Services. Nobody ever heard of Omni Services, but they made hoses, and we had this conversation about hoses and connection integrity, and down into the bowels basically of the data center, and secondary fluid networks and things like that. This is the infrastructure that you're talking about that is hidden. What is the state of that, and how important is that? Because if that fails, it's like when the plumbing in your house goes. No cool water, no hot water. You've got troubles. Can you talk to that?
Yeah, it's interesting. That is like the talk of the town, and that's the work that we're all doing. Here's the changing times. Supercomputing was really full of hardware and data center personnel this year in Atlanta, wasn't it? Right?
It sure was.
You don't normally see that,
Yeah.
but now we are reimagining and re-engineering nearly everything, because a rack in and of itself now, a rack of compute, a rack of servers, used to be a very special thing, and the IT guy takes care of that. And then you get your facilities engineers, and they take care of that. These are two separate things. Not today. These things are one engine. As we move towards 1 megawatt rack, how to cool it, how to manage it, how to operate it, it requires all kinds of PhDs, right? Because we have to think about new metallurgy now. We have to think about the difference in materials that we're dealing with. We have to think about difference in liquid and fluid dynamics, air movement, air volume. Everything is going to change, and we're all working together now, looking at a data center as a unit of compute now, as opposed to two separate things. It's an engine in and of itself. And all of these things are coming together like they've never come in before. You'll hear somebody talk about, oh, well, we fixed the liquid to chip problem because we just took the pumps and the water outside of the rack and we put it over here and made it somebody else's problem. It doesn't really work like that. We are pushing liquid at pressures and temperatures never seen before. So there's a huge amount of work and effort going on. And the cool thing about our industry right now is we're all coming together and we're underneath this problem and looking at this problem of scale, and we're looking at it together. We don't have somebody on the top of the problem, the bottom, like that are polarizing. We are looking at this problem saying, wow, we've got to come together and recreate and reimagine, and not just innovate. We have to transform our industry. So you're seeing transformation happen right now like you've never seen before. And Lambda's a part of that. We have mechanical, electrical engineering people working with the data center space, working with the HPC compute engineers, and we're trying to find the new and best way to deliver this infrastructure technology. It's actually, if you want to geek out on hardware, this is the place to do it right now.
I love it. You know, my colleague David
Yeah.
Vellante and I earlier this year, we forecast the data center market, and we observed, you know, the data center, you know, all in has been a couple of $100 billion. It was like a perpetual, you know, industry at that level, up and down a little. Maybe COVID affected it a little bit, and then all of a sudden it jumped up, you know, last year, you know, to $350+ billion. You know, talking, you know, the infrastructure, the storage, the compute, the power, et cetera, power and cooling. And we were looking at it and saying, wow, this thing is going to continue to grow at, you know, massive, you know, double-digit CAGRs over the next decade. Yeah. So we've got it hitting, you know, call it $1 trillion early next decade. Some people probably have it before that, probably be $500 billion this year. Just never seen anything like this. I mean, just massive, massive growth. Now, when we put that forecast out there, of course, people said to us, yeah, but what about power? What about energy? That's the big limiting factor. And everybody sort of points to that. And the assumption that we made is that the value that's being created here and the productivity boom that is coming, you know, there may be a little downturn, you know, like there always is in these so-called bubbles. But the assumption that we were making is that the industry, to your earlier points, is banding together and will solve this problem. You've got an administration that's aligned with the industry. You're trying to prove that you can deploy energy. I mean, look what they've done with GPUs. You know, trying to compete with DeepSeek, trying to compete with NVIDIA when they were somewhat shackled. So it seems like where there's a will, there's a way for this industry. I wonder if you could address that. Is that overly optimistic? Eric Schmidt says, well, maybe superintelligence is going to solve that problem. Others feel like quantum will be, but that's a ways out. What's your take on the blocker of energy? How do we get through that?
Anytime you experience dramatic change, oftentimes there's an upset or a remixing of the status quo and the way things were. I think we're going to find that in the end of this particular cycle, that the data centers growth actually helps to stabilize and create a better overall grid in every country that they're working in. As it sits now, it feels like we're taxing the grid, because the grid hasn't had to support this type of demand in the past. But as we start growing together and working together, we're going to find that we're going to get through this particular time, and then we're going to actually see a much more stable grid. A lot of the data centers are starting to do on-site power generation. So every one of us, we do think this way. You have to be the most efficient steward of the resources that you consume. You can't just go willy-nilly and just keep building and not actually understand how to be efficient and use these resources wisely. And again, a rising tide floats all boats. We have to work with our partners, our government regulatory commissions, all the utilities. They're accustomed to 20 and 30 years of working like this. We're bringing in a new dynamic now into the grid with lots of data centers spread around the world. And as we start working together and get these data centers up, all of a sudden, maybe more power will be to the grid or able to be distributed better. I see a world where, yes, it's a little chaotic today, but going forward, as long as we all continue to work together to create the type of power generation where you need it, we're going to be okay.
You know, Ken,
it's important to understand there's a lot of power. It's just the power is where you need it. And that's not always true.
you remind me of, the whole art of the possible. I'm reminded of Earl Nightingale. In the 1950s, he put out a video, The Strangest Secret. It was an audio, actually, with his picture. That's what the state of the art back in the 50s. And one of the lines in there was, you don't even have to compete. We live in the greatest land of the world. All you do is create. But somehow, tech became this zero-sum game, and certainly in the 80s and the 90s. But the hyperscalers have shown that you can have 3, 4, and now with companies like yours, more thriving, that it's not a zero-sum game. And the possibilities and the vision that you're laying out they're enormous. I heard Michael Dell on a podcast. It was on the BG2 podcast. They were asking him, are we investing, over-investing? Is this a bubble? And he had a great line. He said, well, the global GDP is, I don't know, $115, $120 trillion. People are talking about 10, 20, 30% productivity impacts. I heard somebody the other day talk about the 8x productivity impact for the developers. So he said, just do the math. We're spending maybe $300-400 billion on data center build-outs this year. Call it $500 billion. 10%, that would bring you to 10, 11, 12 trillion. So his premise was we're underspending. Now again, maybe we hit some trough at some point and everybody freaks out, but the long-term vision that you're laying out is of a different world, solving problems that were previously unsolvable, and driving a productivity boom and potentially a healthcare, transformation like we haven't even been able to envision. I'll leave you with final thoughts on that.
Final thoughts on that really are, when you think about access to technology being a fundamental human right, it's not just about business. We're enhancing the human experience. We're using the technological advancements that we've made, the things that we've unlocked, to act as a force multiplier. We're taking our brain and we're making a bigger hammer, like with that, or a spoon, right? Or another tool to actually bring us forward into this age of intelligence. So to put money on it, it's more like it is about moving humanity forward in a way that everything else will follow. If we really truly want to deploy infrastructure, it takes dollars, it takes money, it takes time, it takes intent, it takes cooperation, it takes will. And Lambda wants to create a platform by which tens of thousands of people who otherwise wouldn't have access to this type of platform to create tools that enhance the human experience. We want to do that. We want to be a part of that. And I do believe that everybody that I talk to in this industry, and I've been in it more than 25 years from the beginning of hyperscale till now, we've built to this point. So Lambda is really excited to be an emerging hyperscaler to help do that, right? That is the goal. The goal is to bring technology to the hands of everybody who can use it.
Well, you're laying out a really exciting vision, Ken. I appreciate you participating in the NYSE Wired and theCUBE's program on data center of the future and AI factories. Thank you so much for being here.
I'm glad to be here, and I'm glad to be part of the intelligence age.
Awesome. All right, and thank you for watching. This is Dave Vellante for John Furrier, the entire CUBE and NYSE Wired team. Keep it right there. We're back with more action right after this short break.